So what is a crystallographic database? So it's a database that includes bibliographic data, so publication details, and then more chemical information, which we'll see, as well as atomic coordinates. Crystallographic databases are special because there's an agreed file format known as the CIF format. Every published structure is added to the appropriate database, and the databases are curated, so there's a level of quality associated with the databases, and hopefully that means that you don't have to invest the time to reprocess the data. So today we're going to be looking at the Cambridge Structural Database, which is a database of over 1.1 million structures. It's got organic and metal organic structural data, but there's other structural databases out there. So the ICSD is the inorganic database. The PDB is the protein data bank, looking at macromolecules. And then there's the ICDD, which is a database of powder diffraction data. So what does the CSD include? It includes every published structure, so that's including structures in scientific articles, in ASCP or early views, structures published directly through the database as CSD communications or in patents, university repositories such as the Southampton University repository, or thesis data. Each individual structure is enriched and annotated by experts, and so not only can you learn about the individual structures, but you can gain new insights from the collection of data. So what can we do with the database? So we can look to see whether a compound already exists. So you can, if it does exist, you can learn about that compound. So you can learn the geometry of the molecule. You can learn how the molecules pack together in a crystal structure. And then it's got other associated experimental information. So you might want to know the recrystallization conditions, the melting point, or you might want to then link out to the paper to find out how to synthesize the compound. You can also learn quality information. So how good was the structure determination, who published it, has the molecule got the ability to crystallize in different forms or different polymorphs, and you can use the information to help determine and validate new structures as well. So as well as the basic lookup, you can do more with the analysis of the collection to learn new insights from the collection of structures. We're primarily going to be focusing on the kind of search and retrieval aspects of the CSD today, but we will give some information at the end about some of the other things that you can do with a database of structural data. So today we're going to be using Conquest. I think you should all have information sent to you via email about how you can install Conquest, and you should all have a 1-month workshop license so you can use it. So if you have got it installed, you should be able to see this icon on your desktop. Alongside Conquest, which is part of CSD Core, which is made available by the CCDC, or the Cambridge Crystallographic Data Centre. We also have online access to the CSD, and there's a free access structure service on our website, and you can also access the more advanced search functionality through our web CSD access. So we're going to start by looking at Conquest. So what types of structural data can we find using Conquest? So as I mentioned, it's a database of all the published organic and metal organic experimental crystal structures. It's got about a half and half split between organic and metal organic. It includes predominantly non-polymeric structures, but there are about 10% of the structures that are polymeric, and we'll learn how you can search for those. It's got single component structures and also multi-component structures. So they're things like co-crystals, solvates, salts. The organic part of the CSD has got drugs, agrochemicals, pigments, explosives, and it's also got about 2,000 different protein ligands. And then the metal organic part of the database. It's got a lot of metal organic frameworks, and they're definitely increasing in number at the moment. And you can use it to do things like look at fundamental chemical bonding. As well as that, it's got additional data, so you can find out the different polymorphic families, things like melting points, colours, shapes, and bioactivity details, and we'll show you how to do that. So what is Conquest and what does it enable you to do? So it enables you to search and retrieve information from the Cambridge Structural Database, and it provides a full range of text numeric database search options. You can also do more complex searching, so you can search based on structure. You can set up 3D geometrical constraints in your searching, and you can also look at some of the bonded and non-bonded contacts. And it has a large range of filtering options. So you might only be interested in the organic part of the database, so you could filter on just that part, or you might want to filter on the quality of the structure. So that's done by looking at R factor. Or you might want to combine your searches. So maybe you've got a number of different things that you want to search for, and we'll be showing you how to combine searches and then export your results after you've done your search. I think when you're looking at databases, it's always important to remember that you can get lots of answers to many important questions, but you need to be careful when constructing your queries, and you need to understand more about the data that you're looking at and the information that you get back. So that's our word of warning for today. So what does Conquest look like? So it's got a range of different search features. So I've mentioned that you can do text numeric searching, you can also do 2D chemical drawing, and you can search for bibliographic details. So we're now going to get to the follow along bit. So if you've installed Conquest or got Conquest available to you, you should see this icon on your desktop, or if you're using Windows, you can go to your Windows bar, go to CCDC, and under there should be Conquest. So at this point, if you want to follow along, now's the chance to press that icon, and you should get this box here. So that's our Conquest window. When you open it, you'll see that there's a number of different search and menu options down the left-hand side. There's some tabs that we're going to be going through today to allow you to explore the results and manage your queries. And there's also some file menu options at the top. And if we look at the file menu options, one of them is view databases. So that gives you information about what databases you can explore. So what versions of the Cambridge Structural Database are available. And it also gives you some subsets. So these allow you to do more targeted searching of the structures of interest. So if you're interested in drug structures, you could just choose to search on the CSD drug subset. So the first thing I'm going to press is the author journal search. So we've opened Conquest and we're going to press author journal. We should then get this pop up here, and it allows you to fill in author name or bibliographic information. So in my search, I've put Laura McCormick in the author name, but if you want to follow along, we're going to choose a slightly easier name to type. So we're going to put Simon Coles, so s.j.coles, and there's no spaces in that. So if we enter that in the author name, and then we press search, that will give us our filtering options, and we can select whether we want to filter out organometallics or powder structures. We're not going to put any filters on this, and we're just going to press search. So once I do that, I will then be presented with the results. So I can see my query is highlighted. I've got options down the left-hand side to see different information about the structures that I'm looking at. And I can also see what results are returned. And these are ordered by something called a ref code, which I'll explain in a minute. We can also see how many results we've got. So we can see that Laura has published 120 crystal structures. So the question for you, if you are following along, is how many results did you get for Simon? And do tell us in the chat box if you want to share your results. So I've mentioned these are called Csd Ref Codes. So what is a ref code? So a ref code is a database reference code for the Cambridge Structural Database. It contains 6 to 8 characters and it's used to identify entries in the database. So the same substances are assigned the same 6-letter code. So this is your 6-letter code here. And then they get an additional 2 numbers if the same if there's other structures with the same substance. So that might be if there's different polymorphs of the same substance, new determinations or refinements of the same substance, or determinations at different temperatures and pressures. Different substances are assigned a different 6-letter ref code, and stereoisomers or different solvates, co-crystals are also assigned a different ref code family. So it's a way of just trying to identify the same substances together and ordering those together. And we can jump to the ref code in a results list just by typing in the ref code box here, or we could search for a ref code when we go to build queries on the left hand side. There's also some quite amusing ref codes. So these are just some of my favourite ref codes, but I'd like to hear what yours are after you've had a chance to explore it further today. When we're looking at the results, so on the pane them on, I can see the search highlighted, so I can see Laura's name, but I could also jump to the publication. So the publication DOI has got a link, and that allows us to explore the associated scientific article. And in most scientific articles, there'll also be a link back, normally based on the deposition number, to the CSD. So you can go from the publication to the data entry, or from the data set to the publication. So we've got these options down the left hand side of our results viewer, and these tell you more information about the structure. So by clicking on crystal, I get to see more crystallographic information, and I can see additional information. For example, we can see that it was recrystallized from DMF. We can see that it had the shape of a needle. If I go to chemical, I can see that it's been given a chemical class, so it's a porphyrin, it's red, and it's got additional experimental information, such as that it's heat sensitive. I can also look at the 2D chemical diagram, and this has been curated at CCDC. I can choose to turn on or off my terminal hydrogen, so you can see here those being displayed. I can, if I want, then go on to use that as a query by pressing use query, and that gives me some options. If I did do a 2D chemical search, I could also see that search highlighted. But if I wanted to explore the structure more, then we've also got the coordinates in 3D. So I can click on the 3D visualizer, and I can actually start to explore the 3 dimensions of the structure and of the molecule. By right-clicking, it enables you to change the display of the 3D visualizer. So I've right-clicked on the 3D visualizer, and I can change the display style. I can turn on or off the disordered atoms, or I could pack the molecule. So if you're following along, you can click down on the left-hand side and just explore the structure a bit more. The other thing that I'm able to do from my view results is to export the entries, and we'll show a bit more detail on this in the demo, but you can export entries, for example, here, and you've got a number of different things, different file types that you can export the entry, either the current entry or the selected entry, and there's other options down here. So that's author and journal name, but what happens if I would like to search for a particular chemical or a particular molecule? So there's a number of ways to do that, and the first one that we're going to look at is using the name class search functionality. So if I go back to my build queries along the top and I click on name class, if you do that, then you get to see this name class box. And you could look for a chemical class. So these help you identify some of our more complicated structures to search for. So you could choose one on the drop down, or I could put in a compound name. So if you're following along, you go to name class and we're going to add a compound name. So the compound name that we're going to add is paracetamol. So in the Cambridge Structural Database, we try and put our UPAC style names, so following chemical naming conventions, as well as more common names when known. So in this case, we've got a more common name. So I add the compound name here and I press add, and it goes into this box on the right, and then I can press search. If I do that, I then get to see my results just like we did when we searched for Laura's name. And you can see in the text information about the structure, it's got a number of different compound names. So I could have used any of these names to search for paracetamol. The other ways I could search for chemicals, I could search via elements, or I could search via formula. If that is of interest, then you need to click on these two options on the left-hand side and then experiment with what information you'd like to see. So there are a number of other ways that you can search for data in the Cambridge Structural Database using Conquest. These are what the pop-ups look like. What we're going to look at in more detail is how to do structure searching. I guess one of the things that we might want to do is look for more of the experimental information that we saw in some of Laura's entries. And so one of the boxes that is quite useful is the text search. So in there we could put the morphology of the structure, or we could put things like bioactivity or heat sensitive. When we do our search, we can either choose to run the search there and then, or if we wanted to do a number of different searches or store up a number of different searches, we could do that and we could press store. So I could search for Laura and I could search for a chemical diagram at the same time if I do store each time, and then just use that query on the front box. The other way I can combine queries is by going to the Combine Query tab, and that allows me to drag and drop different queries in that I want to combine. So either to have, must not have, or have at least one of, or I could manage my hit list. And that allows us to do different things with the results of our queries. And a tip here is you can rename your searches to make it clear as to what you're doing as you go along. So before we go on to the demo, just a quick preview of the draw box. So if we go to build queries and draw, we get this window that enables us to draw a molecule and then set up a search for that molecule. It's got options down the left-hand side to allow you to do things like draw or add 3D constraints. It's also got some templates and rings that are predefined for you, your different elements, your different bond types, and it's got file menu options along the top. So for example, you could auto-generate hydrogen atoms. So to add atoms or bonds, you'd need to go to the draw option. To remove atoms or bonds, you go to arrays, and then you can use your left mouse click to add atoms, and you can use left and drag to attach an atom to an existing atom. You can also right click on an atom or a bond to add extra properties to that atom or bond. And one thing that's probably a good tip when you are constructing queries is if you don't quite know how to draw the structure or what the bond type might be, then you can use any bond. So in this example, we're trying to search for a polymer. And as we draw structures in the CSD, you can see we've got some polymeric bonds here, but I might not know where those polymeric bonds are. So there's a number of different ways that you could construct your query. And if it is likely to be a complicated search, then we'd advise you to use an any bond, and you can then always kind of restrict your search further to allow you to refine the results that you get. So I'm now going to pass over to Ilaria, who's going to take you through in more detail a demo of Conquest in action that you can follow along to. And as we go through, if you have got any questions, please do type them in the chat box and we'll try and answer them as we go through.
Can you hear me and can you see my screen?
Yes.
Perfect. Okay, so by now you're probably familiar with the Conquest interface, but in case you've joined a little later, so we're in Conquest now, and this is the Build Queries tab, which we will use to build all the different searches that we're going to run. There is the Combine Queries tab, which for me is now empty. You will probably see the queries that you've run during the first part, so the search for Simons, structures, and maybe some other searches that you experimented with yourself. Then we have Manage Hit List, which for me again is empty. You will probably see a list of searches here. And then we have the View Results tab, which Susanna has already shown us. And we will see all of these in more detail when I will have a search too. So we're going to see the draw option to build a query. So this is our window, as Susanna showed us, and we have different options at the top, but now they're grayed out because we have not drawn anything. So first thing to do is started drawing. So you can see here we have C, so it means that when we will place an atom, it will be a carbon. And you see it is highlighted also at the bottom left. So we just click and the carbon atom appears. So to create, to connect other atoms, we can just click with the left button and drag. So left click and drag. And this is not the search we're going to run, so feel free to play around with this. We have a number of elements that we can select from the bottom. So in this case, we might want to select the nitrogen. The moment I clicked on it, it replaced it also in the highlight area. And we can either click and drag again, or we could even replace one of the atoms just by just clicking on it. And if we want to select other atoms which are not in this quick access menu, we just click on more. And then we have an option, a series of options, but we can go on other elements. This opens the periodic table. And from here, we could select any element that we want or we need, or we could even select an entire group, or for example, this is any metal. We could even select multiple elements, so maybe we want just these two. And when we're happy with our selection, we just click OK. And this is the selection that we now apply. So in this case, we will have either a bromine or an iodine here. We can also change bonds. So something we can do is right-clicking on a bond, and we can select which type of bond we want. So single, double, triple, and so on. In this case, we might want a double bond, or we can change it from the bottom here. So bond, double. So in this case, we can either click on a bond or just click and drag, and the next bond will be double. So now I've created a bit of a creative structure substructure. So we want to delete this. So we can use erase, and we can either remove a bond or atoms. And of course, if you remove an atom, in this case, it will remove all the bonds attached to it. Or in this case, I just want to clear my drawing area. So I can just go to Edit and Clear All. So now that we're a bit more comfortable with drawing, we can move on to our first search, drawing. So our example will use a ring from the templates. We'll use the aromatic ring. And from here, we will connect a nitrogen. So we need to select nitrogen and drag. From here, we want 2 oxygens with the double bonds. So select the oxygen, and I will show again the 2 ways. You can use the way you prefer. So I click and drag, and we have the oxygen. Right click on the bond, type double, or I can select double bond at the bottom, and now I drag, and I have my oxygen with the double bond. The last atom I need to add is a chlorine with a single bond. So I selected chlorine and single, and I'm gonna drag it from here. Perfect. So this is the substructure that we're going to search. And now that we have created it, we can hit search at the bottom here. Search. Perfect. We have our search setup window coming up, and we have a series of filters. And this time we want to set some filters. So we want structures with the 3D coordinates determined, and we want only organics. You can play around and see how the results will differ if you select other filters. You can also notice here there is a search name, and it's search 1. It might be different for you if you've been running other searches, and we can change it. So we can make sure we don't confuse our searches, and I will call it substructure A. Okay, so we change the name, we have the filters, everything looks good, and we start the search. Okay, so now we are in the view results, and we might have missed it for a bit, but here we saw the progress of the loading of the search. We have on the right-hand side the list of ref codes of structures. We contain our substructures that we drew. And we see in red, as Susanna mentioned, what we search for is highlighted in red. We also have the alt text option with all the information about the author, the journal, the chemical information, this information about the crystal structure, and the experiment. And this is also broken down into more convenient place subgroups here. So we have the 2D diagram, and we have also the 3D visualizer. So we can see our structure in 3D. So you can notice that one part of the structure is a bit darker than the other. This is because the substructure we search for is highlighted. We can untick from the bottom left here, and all of it will look the same. I will decide to keep it ticked. To have a bit thicker wireframes, we can right-click at any place. We can go to Settings and click Thicken Wireframe. So this should be a bit more visible also for you. And if we right-click again in Settings, we can also select Show Circles for Aromatics. So now our aromatic string have the circle, and we can see the packing as well. So again, right-click, packing, 1 unit cell. Okay, so these settings will be carried on for the other molecules in your search, the other ref codes. I decided to remove the packing because it might be slower sharing screen, but you can visualize it as you prefer. Okay, so we view these results, and there are two things to observe now. One thing is that we can export these structures to visualize or analyze them in Mercury. So last week we saw how many things you can do in Mercury, how you can improve visualization and make nice image, you can measure distances and so on. So if you go to analyze hit list, visualize structures or analyze data will bring this list of structures to your Mercury. You can also export the results, so you can save them as a PDF, or you can export and then again view in Mercury and analyze in Mercury or view in Excel. And okay, so we have run our first search. We observe that we have 366 hits, which is not that many compared to 1.1 million structures in the CSD, but we might want to refine this search even further. So, for example, in this case, we are interested in structures which were published during or after 2016. So how do we do that? We go back to build queries, and this time we prepare a search from author journal. So before, you've tried to look for an author name. So we search for Simon's and for Laura's structures. This time we will use the year. So we go to year and select during or after, and we put year 2016. In this case, we're going to store the search, and we will see how to combine these two searches so that we will obtain substructure A only for structure published during or after 2016. The first thing you could do would be ticking both these queries and start the search. From here, we are going to see a different way. We're going to use the Combine Queries tab. So you see on the left-hand side, there are 3 different boxes which correspond to must have, so corresponding to the Boolean and, must not have, so not, and must have at least one of, or. So what does it mean? If we put query A, so our substructure in must have, and we put query 2, so during or after 2016 in not, it will find structure which have this substructure, but are not as in query 2, so will not be published during or after 2016. If we put this in or, both of them, must have at least one of, it will find actually even more structure than the ones we find before, because it will be having substructure A or being published during or after 2016. So what we want is to use the and. So we want the results to have substructure A and to be published during or after 2016. So we are now ready to search. The filters are the same as before, so we are happy with it, and we start search. So the search is complete, and this time, as you can see, we have 91 hits, so we have refined the hit, the search. So a thing that we can observe is that the substructure is again highlighted in red, and in the alt text, we should see the year highlighted in author journal. Here it is. So year 2020. So the year is also highlighted. Okay, perfect. So there is a tab that we have not seen yet. So let's go to the Manage Hit List tab. So you can see I have my first search stored here and search 2, which is the one that I've just run. You might have more structures, or you might want to change this, more searches, sorry, or might want to change these names. So you can do it from here as well. So you select your search, hit rename, and you can put a new name. So let's call it A during let's do from 2016 version 1. Why version 1? Because there's another way to do it. Actually, this would be version 2 because we mentioned another one. So if we are all happy up to here, we can see the third way to do it. So we can go back to build queries. We want to obtain the same exact result, but just in a different way. So we reopen query 2, clicking edit, and we are still happy with this definition, during or after 2016. This time we search. We don't want to overwrite the existing query. So what we're going to do now is not to search the entire CSD and then combine the queries, but to limit the search to be in the first search that we did. So to be within this subset of structures that we defined. And here the keyword is subset. So we do need to select a subset. Just to mention, if you were to use one of these subsets that are created by the CSD that you saw before in the presentation, you would select the second dot in the restrict search window. So the second option would be entries in a predefined hit list, and you have all the subsets created by the CSD. In this case, we are not interested in it. We are interested in the entries in a hit list loaded in this session. And here you should see all the searches that you've run so far. We are interested in searching within substructure A search. So the moment I clicked it, you see it loaded. We can check, we have the 366 ref codes, so perfect. Okay, and we can change the name or not. I will not change it now, and we can start the search. Okay, the search is completed, so we have again 91 hits, and they look familiar, so that's great. You can see that we don't have the substructure highlighted this time because our search term was the year, so only the year is highlighted now. And if we go back to manage hit list, I just wanted to show you, okay, the number of hits is the same. And if we want again to view one of the previous search, the results from one of them, you just select your hit list and hit view, and you view it in the results diagram. So this is the first search we ran with 366. Okay, so we saw 3 different ways to combine queries from the build queries tab, selecting and searching, which we didn't do, we just mentioned. From the combine queries tab, dragging our queries, one was run and one was only stored, into the boxes, and then from searching within a subset of a search that we already ran. There is a final way. Well, I don't know if it's final. There might be more ways because Conquest is a bit various. You can do the same thing in many different ways. So another way we want to show you today is to combine hit list from the Manage Hit List tab. In this case, we want to search for structures from the substructures A group, which were published before 2016, so which do not include the ones that we have already found. So we select list A, substructure A, and list B, any of the other 2, because we said they are the same. Let's select the first version. So we now can generate a list of entries which are common to list A and list B in either list A or list B, and in list A but not in list B. So what we want to do is having structures in list A, so which contain substructure A, but are not in list B, so which are not published from 2016 onwards. And we just click OK. So we have a new combination here, so a new hit list called combination 1, which contains 275 structures, which is indeed the difference. If we want to view these structures, again, we hit View at the bottom. So we can now view all the structures. And we can also rename this if we want, clicking on rename. So, and I think this concludes the demo. So I will pass back to Susanna. You're still muted.
Great, thank you, Ilaria. Thank you for the push about muting. So while you are getting your questions lined up in the chat box, let's just have a quick review of what we've learned. So hopefully you've learned how to search over 1 million published crystal structures using Conquest. You can now build your queries from the drawer window, or you can use different ways to build the queries via name or journal search. We've also seen from Ilaria how you could edit and combine queries and view hit lists. There's a lot that we didn't have time to show you today. So in the drawer menu, you can also construct 3D searching. So you could search for different distances or angles in a structure. You could look for intermolecular interactions. You can explore the targeted subsets more. So that's things like the drug subsets, MOF subsets, COVID-19 subsets. So they're the targeted sets of data of interest. And there's more that you can do with exporting and analysing data. And we could also combine the tools that we've learnt in the various, the last 2 sessions to analyse the data more. So in Mercury, that we learnt about last time, you can go from Conquest to analyse data in Mercury. And you can then start to use other tools like Mogul to look at the geometry of the structures in the database, and you can really learn about the geometry of particular elements and particular molecules. If you don't have Conquest installed on your desktop or laptop, but you want to explore the structural data, we also have web interfaces. So Access Structures is a free service that you can access via this link here that allows you to view and retrieve every entry in the Cambridge structural database or the inorganic database. And every entry is for you to view, free to view and download. If you want to do more advanced searching, then we've got WebCSD for licensed users, and that's got some of the same search functionality as Conquest that we've just seen. It's just not quite as in-depth at the moment. If you've enjoyed learning about Conquest and want access after the current license for the workshop, then as I've said, you can use Access Structures. You should all have a 1-month trial license for Conquest through this workshop, and that entitles you not only to explore Conquest, but all of the other software in CSD course. So that includes Mogul and it includes Mercury. If you're a UK academic, then you automatically get online access to WebCSD and you get remote desktop access to CSD core software. And I've put the link to the PSDS service that provides this UK academic access here. And I think you need to register, and Simon and Rob can provide more information about that. It's also important to say that most university chemistry departments worldwide already have a license to the CSD. You might just not know about it. I've put some of the UK universities that I know that have a license, and I'm sure there's more that do, on the right hand side here. So if you do want a license and do want to explore more, then do either get in touch with us or the PSDS service, and I'm sure we can help you get set up. If you did want to explore more, then we have got resources on our website. So you need to go to the CCDC website, community, and then training and educational resources. We've got self-guided workshops, so you could have a self-guided workshop on Conquest or some of our other tools using this link. And we've also got some instructional videos on YouTube and LabTube, and this would be the link that you'd need to go to. If you want to look back at what we've learnt in the last 3 sessions with the NCS, and then coming soon are the recordings of these sessions and a feedback survey. And if you want to learn more from CCDC, then we've just announced our next series of CCDC virtual workshops. So we're looking at Mercury intermediate level on the 7th of April, CSD cross minor, which is pharmacophore searching across the CSD and the PDB on the 14th of April, and then programmatic access to the CSD via our CSD Python API on the 21st of April, and registrations available on our website. So I think that concluded our slides. We're now here to answer any questions that you may have for us on Conquest or anything else that you've learnt about in the last 3 sessions.